The James Webb Space Telescope, or JWST, is a space observatory developed directly by NASA, the European Space Agency, and the Canadian Space Agency. It is planned to succeed the Hubble Space Telescope as part of NASA's flagship astrophysics mission. The James Webb Telescope, launched on December 25, 2021, will provide improved accuracy and sensitivity that surpasses the Hubble telescope and will succeed the outdated Spitzer Space Telescope in 2020. The James Webb Space Telescope will be located 1.5 million kilometers behind the Earth and the Sun at the L2 Lagrangian point. And it will hover around that point in a circular orbit to make an observation. It will enable a wide range of investigations in astronomy and cosmology, including the observation of some of the most distant astronomical events and objects in the universe, such as the formation of the first galaxies, and the detailed characterization of the atmospheres of potentially habitable exoplanets. The primary mirror of the James Webb Telescope, the telescope's optical element, consists of 18 pieces of gold-plated beryllium hexagonal mirrors that combine to form a mirror 6.5 meters, 21 feet, in diameter, much larger than the 2.4 m, 7 feet 10 feet, Hubble mirror inches. Unlike Hubble, which detects near-ultraviolet, visible, and near-infrared, from 0.1 to 1 micrometer, the James Webb Telescope will observe in a lower frequency range, from long-wavelength visible light to mid-infrared. From 0.6 to 28.3 micrometers, which would allow it to detect high redshift objects that would be very old and very far from us, and the Hubble Space Telescope cannot detect in that infrared range. The telescope must be kept too cold to be able to detect infrared radiation without outside interference, so it will deploy into space near the Sun-Earth Lagrange point L2, and will keep the large silicon and aluminum-encased Captain solar shield and its mirror and instrument temperature below 50 K. NASA's Goddard Space Flight Center development efforts, and the Institute of Space Science Observatories operated the Webb telescope after its launch. The principal contractor is Northrop Grumman. It is named after James Edwin Webb, who was administrator of NASA from 1961 to 1968 and played a key role in the Apollo program. Costs, and underwent a major redesign in 2005. The James Webb Telescope was completed in late 2016, after which the intensive testing phase began. In March 2018, NASA postponed the launch after the Sun's shield was torn during deployment practice. It delayed the launch again in June 2018 following recommendations from an independent review board. Work on the integration and testing of the telescope was suspended in March 2020 due to the coronavirus pandemic, leading to further delays. After work resumed, NASA announced that the launch date had been pushed back to October 31, 2021. Problems with the Ariane 5 launch vehicle led to the launch date being pushed back to December 25, 2021. Features: rough plot of the Earth's atmospheric transmittance, or opacity, for different wavelengths of electromagnetic radiation, including visible light. Preparing the launch of the James Webb Telescope at Ariane 5. The James Webb Space Telescope has a predicted mass about half the mass of the Hubble Space Telescope, but its primary mirror, a 6.5 meters, 21 feet, gold-plated beryllium reflector, will have a 6 times larger collection area, 25.4 sqm, 273 square feet, using 18 hexagonal mirrors with a blackout of 0.9 square meters, 9.7 square feet, for the secondary support trusses. The James Webb Telescope is equipped with near-infrared measuring instruments, but can also see orange and red visible light, as well as the mid-infrared region, depending on the instrumentation. The design gives special importance to the near to mid-infrared range for three main reasons. Objects with a high redshift turn their visible emissions into infrared radiation. Cold objects such as debris disks and planets emit more infrared radiation. This range is difficult to study from Earth with existing space telescopes such as Hubble. Ground-based telescopes look through the Earth's atmosphere, which is opaque in many infrared ranges. Even when the atmosphere is transparent, many of the chemical compounds in the air, such as water, carbon dioxide and methane, are also present in the Earth's atmosphere, which greatly complicates analysis. Existing space telescopes such as Hubble cannot study these ranges because their mirrors are not cool enough. Hubble mirror is kept at about 15 degrees Celsius, 288 degrees Celsius, 59 degrees Fahrenheit, and thus the telescope itself radiates strongly in the ray bands. Infrared thus hinders monitoring and imaging. The James Webb Telescope will operate near the L2 Lagrange point of the Sun-Earth orbit, about 1,500,000 kilometers, 930,000 miles, outside Earth's orbit. By comparison, the Hubble telescope orbits 550 kilometers, 340 miles, above Earth's surface, and the Moon is 384,400 kilometers, 238,900 miles, from Earth. This distance makes repairing or upgrading the James Webb Telescope's instruments after launch almost impossible by spaceships or astronauts during the telescope's operational phase. Objects close to the Lagrange point could orbit the Sun in conjunction with the Earth, which would allow the telescope to stay at a roughly constant distance, and use a single solar shield to block out heat and light from the Sun and Earth. This arrangement will keep the telescope's temperature below 50 K, minus 223 degrees Celsius, minus 370 degrees Fahrenheit, which is necessary for infrared observations. Follow us in the next episode, as we continue the journey of the giant James Webb Telescope.